Okay. All right. Chapter 10, section 2. Okay, it's on arcs. So major, minor, semicircle, arc measurement. I'm also going to touch on, start leading into the types of angles. So the only two with arcs we're going to be worried about or concerned about are going to be central and inscribed angles. But we're going to start with the number of degrees in a circle. Circles have 360 degrees. And also the arc measurement, if we're talking about the degrees or the motion, how far they've moved, or how far apart 2 points are, in degrees, that is also 360 degrees. So our outside degrees are going to equal the interior degrees. So whatever the sum of our interior is will be the sum of the outside in degrees. So that is not going to change. So 3 arcs. We have minor arc, major arc, and then a specific arc, which is a semicircle. Minor arcs are going to be between 0 and 180 degrees. Okay. So a minor arc is going to be less than a semicircle. So AB is our diameter, which divides the circle into 2 halves. So we have our first half on the right, second half on the, second half right, first half left. Okay. Down here we have a small piece of the pie. So think of the arcs as the crust of a pie or the crust on your pizza. So from A to D, and here's our angle, center will be T. Okay, so our arc is AD, because we're looking at the distance from A to D. And to name an arc, we use the 2 points that we're looking at the distance between, or the movement of, if we're going from A to D, and I put a protractor down, what's that angle? That's what that arc is. It's the crust, it's the angle. This is probably going to be about a 60-degree angle. All right. Okay, this up here, okay, this is between B and D, is another arc. Okay, it's less than the semicircle as well. So we're going to name it with the 2 points, B and D. Okay, just like when we name a line segment, it doesn't matter if I call this arc AD or DA. It's still going to be the same degree measurement as with B and D. It doesn't matter if I go from D to B or B back to D. It's still going to be whatever that angle is. And if this is 60, I should fill these in as I go. This was going to be 120 because this is your diameter, which is a straight line. Straight lines measure 180 degrees. So remember, your semicircle is what it is. It's going to measure 180 degrees. So it's exactly 180 degrees, no more, no less. A major arc is going to be greater than a semicircle. So that means I'm going to start at 1 point on the circle, and I'm going to go halfway around plus more. So I can actually start with A to B to C, which is a major arc, because I'm going from A to B, half the circle, then to C. So when we name a major arc, we're going to use 3 points that are on the circle, and we go in the direction, it doesn't matter if we're going clockwise or counterclockwise. We're going to start with the starting point and go all the way around to where we're going to end. Okay, so from A to B to C is a major arc. Okay. I can now also start at A, go around to B, and then to D. So I can actually name it A, C, D, or I can use A, B, then D. It's as long as I have 3 points, and one of those points has to be between the beginning and end point. So A, B, D, or I'm going to call it D, C, A. Okay, put a little rainbow above because that tells us that we're actually looking at the motion on the outside of a circle, or you're looking at the crust of your pizza and your pie. So these are between 180 and 360. Never equal to, but between. is if we get to 360 degrees, that's like starting at point C and coming all the way back to point C. We're right back where we started, so there's no change in the distance traveled. It just means that I've come right back to start. Okay? That has applications to physics, so pre-calculus. Okay, this is like a bridge to pre-calculus right now. When we come back to where we started, it's like there's no change in our position. We're back to where we began. Okay. The two angles that we're going to focus on are going to be your central angle and your inscribed angle. The other two I'll do in a separate lesson because they're a bit more involved. But your central angle is your angle who's with the center as its vertex. Okay? And when I know the measurement of a central angle, I know the arc distance, or the arc distance, the measurement of this arc in degrees. So if I know that this measures 60 degrees, that's exactly what this is. This is going to be 60 degrees. Right? If this is 120 degrees, this is 120 degrees. Okay, and this is a semicircle, so that means I'm going to have 180 degrees. Okay, and I'm going to check everything by, if this all adds up to 360, I know my measurements are correct. I know I used my central angle theorem correctly. So we know this is true because it's been proven, and then there's also a postulate. It just makes sense. Okay. The inscribed angle is different. The vertex is on the circle. So what we're going to do, we're going to take C, and I'm going to draw one arm of the angle to point A, and the other is going to go to point B. Okay. So here I have this angle, right? And if we notice, this is going from A to B, so that means that this side of the triangle formed is a diameter. Or if I just look at from A to D to B, I have a semicircle which measures 180 degrees. Okay? This angle in here is not 180 because it'd be a straight line if it were. This is actually a right angle. It's 90 degrees. Okay? And so our theorem is that if this inscribed angle is always half the arc distance. So inscribed, your vertex is on the circle. The other 2 points are on the circle. So it looks like you're making a triangle. And this is going to be half of the arc. Okay? Half your arc measurement. And the M means measurement. You're looking at a number. So if I had an inscribed angle that is 30 degrees. So it's on, so if I can do 30, yeah, it looks like it's about right. So 30, okay? That means to find the arc length, I'm going to double what that is. So it's 2 times 30, or 60 degrees. So when I go from this small portion to the large one, I'm multiplying by 2. So if we're going from the inside of the circle to the outside, with an inscribed angle, it's multiplied by 2. If I'm going from the outside, okay, this one looks like it, I'll make this a 48 degree angle. Okay, if I know my arc is 48, I want to know what my inscribed angle is. That means I'm going to take 48 degrees and I'm going to divide by 2 because I'm going from the outside to the interior, or that inscribed portion. So our angle is 24 degrees. Okay, I hope you enjoy. I hope this helps. Thank you.